Hello students, today we consider question on probability and statistics paper 7, that is S2. The code is 9709/72, taken October/November 2015. And the question of interest that we want to look at concerns distributions, and more specifically the Poisson distribution. So the question is question 5. On average, 1 in 2,500 adults has a certain medical condition. Roman 1. Use a suitable approximation to find the probability that in a random sample of 4,000 people, more than 3 have this condition. 3 marks. In a random sample of n people, where n is large, the probability that none has the condition is less than 0.05. Find the smallest possible value of n. That's 4 marks. So let's get to see what the solution is. Well, the question, as we have seen, reads, on average, 1 in 2,500 adults has a certain medical condition. Roman 1, use a suitable approximation to find the probability that in a random sample of 4,000 people, more than 3 have this condition. Roman 2, in a random sample of n people, where n is large, the probability that none has the condition is less than 0.05. Find the smallest possible value of n. Now, those are the questions that we are given. And first thing that we need to remember is that we have the probability. Okay, first we are told 1, like out of 2,500 people, you find that 1 has a condition. Out of 2,500 people, at least 1, you find that 1 has a medical condition. But then we are told that use a suitable approximation to find the probability that in a random sample of 4,000 people, more than 3 have this condition. So it then means that the first thing we need to do is to define the lambda. So in this case, our lambda, since Poisson formula, if we are to get probability that x takes a particular value, that we are going to get by this particular expression. Is the formula. Yes, it is lambda. This is lambda. And times lambda raised to power x over x factorial. Now, this is the Poisson expression. This is the formula for getting the Poisson probability of a Poisson variable. So lambda here just implies the rate, the mean rate of observation of interest, and x will consider the counts, whether first, second, third, etc. up to n. So having this, it then means that E is the usual E that we know. X will be guided on how X should behave. So the only what we need then to get here, the parameter we need is, whose value we need is lambda. Yeah, so that's the only parameter whose value we require here. And we see that going by that information, our lambda is then supposed to be 4,000 divided by 2,500, which is going to give us, because if 2,500 is 1, then 4,000 would be 4,000 times 1 divided by 2,500. So basically that's what I bring here, and I get 1.6. And so I have a lambda of 1.6. Now, for detailed explanation or guidance on what goes on, specifically with the Poisson distribution, that is the probability paper 6, advanced level students, I urge you to visit our website. Just type mathematics, economics, and finance online school. Once you visit our website, you'll find a lot of interesting resources, and we also offer tuition. So if you want to get tuition on what a Poisson distribution is, kindly visit our website, so that you are guided appropriately, and you'll also have the opportunity to access some of the resources that we have. So for now, what we for this particular question, what we'll do, the question is, use a suitable approximation to find the probability that in a random sample of 4,000 people, more than 3 have this condition. Now, if our interest is more than 3, then we can first find the probability that 3, then subtract that probability that 3 people okay, more than 3 have this condition. So first we get the probability that 3 people have this condition, then subtract that from 1 for us to get the probability that in a random sample of 4,000 people, more than 3 people have this condition. So first thing that we'll do, I first want to get the probability of 3. So probability that x is indeed 3 will be e raised to power 1.6 times 1.6 over x factorial and here raised to power x, like that. That's what we are going to have. And being that it is, so what I need to do is it should be, it's the summation. Let me just put everything under this summation, so that I have summation from x is equal to 0 to x is equal to 3 of e minus 1.6 raised to power x over x factorial. So it means that here I'll be having first case. I can factorize this because I can factorize it. I can bring it outside because it does not have any element of x, and so is not affected by the summation. So I have here this in bracket summation. Actually, let me just put summation, not in bracket, not necessarily in bracket, so that I have x is 0 to x is 3 of 1.6 raised to power x over x factorial. So we take cases. The first case will be e raised to power negative 1.6. Now in bracket, we take the case where x is 0. When x is 0, this will be 1. So we have a 1 there. Plus, when x is 1, we have 1.6 over 1, which is just 1.6. Plus, when x is 2, now we have 1.6 squared over 2 factorial. Plus, when x is 3, we have 1.6 cubed over 3 factorial, like that. So what you'll need to do is to work out everything inside here. and multiply by this. If you do that successfully, then the value that you should be getting for that particular part, just that particular part. Now, realize that this gives you the probability that x is 3 or less. It gives you probability that x is 3 or less. So for us to, and that is this probability that this is, that x is 3 or less is given by this expression. So it means for us to get the probability that x is 3 or greater, we'll have to subtract this from 1. And that then means that probability that x is greater than 3 will then be 1 minus the whole of this expression. So if you work out all this, if you work out this, whatever is inside here, and you subtract it from 1, the value that you should be getting is 0.0788. 0.0788. And just remember that this particular probability is obtained by getting, actually probability that x is greater than 3 is given by 1 minus probability that x is 3. And this is x is 3 or less. X is 3 or less. X is 3 or less than 3. So, but this is specifically greater than. So we have that. So that answers part. Yeah. And this here is the probability that x is 3 or less. All of this. So it means you'd have to get this, subtract it from 1 to get this. That's the answer. Okay. And as I said, if you want to learn this as a beginner, you visit our website, so that we have tailor-made courses for you, which specifically follow the syllabus for that particular class, or particular exam that you are preparing for. The website is Mathematics, Economics, and Finance Online School. So, part two. In a random sample of n people, let me just wrap this to create space. In a random sample of n people, where n is large, the probability that none has the condition is less than 0.05. So first, we define our lambda here. Our lambda in this case will now be n over 2,500. Yes, that is n. Because in this case, when it was this, we had it to be, our n was 4,000, but now we don't have it. So we have that expression there. But realize that we are saying that the formula for Poisson distribution is this. This is the formula. But we are saying probably that none has the condition. None having the condition should mean that our x here is 0. And the consequence of having x 0 means 0 factorial is 1. And the number raised to power 0 is 1. So it means the whole of this reduces to 1. And I'm left with e raised to power negative lambda. So I will say here that e raised to power negative lambda should be, we are told is less than 0.05. That's what we are told. It is less than 0.05. 0.05. And we're asked to find the value of n. So what we then do, since we know what alpha is, we know what lambda is, we'll then come here and say, that e raised to power negative n over 2,500 is less than 0.05. And so we introduce lns. We introduce the natural logarithm. If we introduce the natural logarithm, it means that we'll be having negative of n over 2,500, negative of n over 2,500 is less than ln, again, now ln of 0.05. Ln of 0.05. Now, in essence, what we have is that introducing a natural logarithm on this has the effect of having just this. And again, these are some tricks that we use in navigating such kind of problems. And if you need a lot of familiarity with this, you find step-by-step guidance on our website. Now, here, this then should imply that if you already have this, we are now saying that, but we can read ln of natural logarithm of 0.05 can be read. And so what we are simply saying there is that if you work out the value of n, it should give you n, the value of n that we get is n is greater than, just going by this. Now the effect of this negative sign in your operations will have, if you divide everything by negative, that will have the effect of switching the direction of this, and that's why we'll be having this here. So n is greater than 7489.3. 7489.3. Now, if you use your calculator, if you make n the subject, use your calculator, you should be able to get this. But the question is asking us to find the smallest n. So in this case, the smallest value of n that we can ever get is, we say, 7490. And that is the value of n. And so if you followed that procedure up to this particular part, you should have been able to score full marks in this particular question. So up to there, I urge you to follow me to my next video. And if should you need close attention as to how to navigate such kind of questions without any difficulty, you better visit our website. Up to there, meet you in my next video.